All right. So it was take two, which is a minute ago. Now it is take three. Apparently not as tech savvy as I thought. So let's get into it. This is my math project, doing it on derivatives. Now, first simple question you might think is, what even is a derivative? It's a good question. I didn't know for a long time. I do now, though. Thank goodness. it is, it's the definition is a rate of change of a function with respect to a variable. Now, at first, it doesn't seem too bad, but then you remember rate of change, rise over run, all that good stuff. It feels a little bit more easy to understand now. And so, with a derivative, you just pull the exponent out, multiply by the constant in the front, or if it isn't in one, just pull that exponent out to the front, and then minus that exponent by 1. So in this case, 3x to the fifth, you'll do the rule for that. You'll just do 5 times 3, 15, minus 1 on the exponent, 4. As simple as that. Now you might be thinking, so what am I going to use these for? I'm not going to use this. And I mean, you're not too terribly wrong. However, what they can be used for is to find the equation of a tangent line that is on a graph at a particular point. It just helps you understand where these are at on a graph in a simpler, how do I say it, in a simpler fashion. There we go. They can be used to find the minimum and maximum points on a graph. It would help you find, the points of inflection and other topics that we'll cover in just a moment. And now we get to the fun part, the rules of derivatives. There's 5 different types. We have the constant rule, the power rule, the product rule, the quotient rule, and the chain rule. Now, these are just the 5 most common. That doesn't mean that these are every single differential rule. These are just the easiest and the ones that we get through in calculus the first time. Right now, constant rule is probably the easiest one to understand, and the power rule is second best. Excuse me. Product rule can be a little tricky at first, but just do 1d2, 2d1. Basically, take the first, have just the first equal part of the equation, and then derivative of the second one plus the second part plus the derivative of the first part. It sounds a little iffy, but once you understand what that means, you'll be able to put 2 and 2 together, and it makes tons more sense. And the quotient rule is a nice little, what's the word for it? I don't want to say ad lib, but like, I can't remember the name of it. It's, you'll just do low d high, high d low over low low, which means the low, if it's in a quotient, you'll have the denominator take the low as is, take the derivative of the high, and then you'll minus that from the high minus the derivative of the low, or multiply by the derivative of the low, and then put all that over low low. So if you have x squared, you just do x squared to the squared. Very simple, easy to understand. It seems a lot at first, but once you get going, it's really not too terrible. And with the trig functions, these help us be able to understand angle measures, trying to find out if it's in radians or degrees, help us find a point on a circle, help us find velocity and acceleration, the second and third derivative, which we'll cover in just a moment. These are a little tricky just because it can be kind of hard to understand the sine, cosine, and then cosine is negative sine squared, negative sine x, and then vice versa, and all that good fun stuff. Oh, excuse me. Now, the first derivative, this one tells us if the function is increasing or decreasing by finding like the local extrema, or as we say, the relative extrema. And then you can do the maximum extrema, which is the highest highest maximum or minimum extrema you can find. And then the second derivative, this will tell us about the concavity, the inflection points, and any changes in the curvature, just to tell us if we have anything important that we need to understand other than just if it's going up or down. I feel like I'm a little bit out of breath. Goodness. Probably need to slow down just a little bit. I need to make this to 5 minutes. All right, the limits. Limits are used to find derivatives. These are determined the derivative. The derivative. I can't say that word. You don't understand what I mean. Direct substitution can be used for this. So let's say delta x as it approaches zeros, you just substitute 0 in for delta x, and then boom, you'll have your equation basically just plugging in zeros to every spot. You'll be able to find out what that equals to. So if you see the problem on here, 10x to the third, take the derivative of that, it's just 10. Ooh. Different examples we have, we can use them for all sorts of things, help us find the rate of change, the actual inflection point of inflection, or like the critical points, absolute value, all that good stuff. So this is something I thought of as I was doing it, that I realized that math can be incorporated into a lot of different things, one being drums. I picked up drums when I was like a baby. My dad was playing drums in a cover band that he had with his buddies. Just going to town, I'd be in the front row in like a little baby stroller, just having a blast. And then after 18 years, I finally got my first drum set, having a blast, and then realized that like as I'm taking more math classes, that I'm understanding how math gets incorporated into drumming, with like increasing and decreasing and just all that. It's amazing how that works. So with the derivative, the velocity and acceleration, the second and third derivative, they're important because if you take the first one, this will tell you your velocity. Or excuse me, the first and second. I don't know why I said second and third. The second derivative will tell you the acceleration, how fast it's going, or how quickly it gets up to that speed. And they're all with respect to time. And there's to be an equation. Acceleration, the equation must include at least an x to the squared. I thought that's just, stuff like that's just really cool. And so to kind of wrap that all up, I guess, how do we use derivatives in our everyday life? Is we don't really realize it, but we're using it pretty much in everyday uses, like playing football. You'd be able to calculate the arc. Playing games, we need to lead shots. There's someone banging on my wall right now. That's terrifying. I'm sorry about that. You'll be able to see if you need to hit somebody, hit a target from a certain distance out and a certain speed. You have to be able to lead the shot, or you have to be able to predict where something's going using speed and direction. First and second derivative. And so I find it amazing how that works. But I believe that is all for the moment. I will see everybody later. Bye.